Hi everyone, we're going to look at section 3.5. It starts on page 136, but we already learned all about slope. So I'm going to skip this first part of the section and I'm going to go on to the next part of the section. So we're going to start talking about slope-intercept form. So slope-intercept form is for a linear equation and it's of the form y equals mx plus b. So in the form, the m and the b stand for something special in our line. The m stands for the slope and the b stands for the y-intercept. The x and the y are our variables. Remember, x is the independent variable and the y is the dependent variable. And together, x and y form an ordered pair that stands for any point along the line. So I'm just gonna show you what I have written down here for my notes. Maybe pause the video so that you can copy these notes down. So again, m stands for our slope and b stands for our y-intercept of the line. So we're gonna start off with looking at example 3. In example 3, it says find the slope and the y-intercept of the graph of each line. So we're gonna start with y equals 3x minus 4. So in this equation, it's already in slope-intercept form. This looks like y equals mx plus b. It doesn't say plus, but remember minus is just the same thing as saying plus negative. So this is the same exact form. So in our equation, our slope is the m, that would be represented by the 3, and our y-intercept would be the negative 4, that would be our b. So that's all we have to identify. Our slope is 3 and our y-intercept is 4. Let's look at letter B. Now this equation is a little bit different because there is no x term. It's only y equals 6.5. So you might remember this from section 3.4. If it's just an equation that says y equals a number, it would just be a horizontal line. Now think about the slope of a horizontal line. We know that the slope of a horizontal line is 0, and that's why there's no x term, because technically the equation is y equals 0x plus 6.5, and we know that 0 times anything just cancels this term out, so that's why it's not there. But it really is, and it does have a slope of 0. So our slope in this equation is 0, and our y-intercept of this equation is 6.5. Let's talk about letter C. So in letter C, negative 5x minus y equals negative 2. In this equation, it is not in slope-intercept form. So because this equation is not in slope-intercept form, we need to first change the equation into slope-intercept form so that we can see the m and the b. So let's look at the steps down here. So we're going to rewrite the equation by solving for y. So it's y equals. Okay, our first step is we want to add 5x to both sides. And when they do that, notice how they kept it negative y. Don't lose that negative in front of the y. And then they wrote the variable term before the constant term, so you can start seeing it's getting into that form of y equals mx plus b. And that's why we were practicing doing this back in chapter 1. So we're almost there. We still need to get rid of this negative in front of the y. Remember, there's really a negative 1 in front of this y, so we're going to divide it. We're dividing both sides by negative 1, and don't forget we're doing the heart method. So 5x gets divided by negative 1 to give us negative 5x, and negative 2 gets divided by negative 1 to give us positive 2. So now look at this equation. Y equals negative 5x plus 2. Now it's in slope-intercept form. Y equals mx plus b. Our m, the slope, is negative 5. And our b, the y-intercept, is 2. Okay, so that's just identifying what we're looking at for our m and our b. Okay, let's go on to the next page here. So now we are going to use slope-intercept form to graph. Before we look at this example, I'm going to write down some steps that we need to do in order to graph using slope-intercept form. All right, our first step that we need to make sure that we have is that our equation is in the right form. We want our equation form to be y equals mx plus b. We want it to be in this form so that we can easily graph it using these steps here. Okay, once we have our equation in y equals mx plus b, our second step is we want to identify the m, which is our slope, and the b, which is our y-intercept. So just like how we did in that last example, we're just saying what is the slope and what is the y-intercept, and those are the two things that we're going to use to make our graph. Our next step, step number 3, is we are going to plot a point on the y-intercept. So whatever the b is, whatever that y-intercept is, we're going to plot that point on the y-axis. Remember, the y-intercept stands for the point where the line crosses the y-axis. So we're going to plot the y-intercept on the y-axis. Our last step, step number 4, is now we're going to use our slope, which remember is our m. We're going to use it as rise over run to get to the next point, So we're literally going to start from the y-intercept that we already plotted, and we're going to count how many we're rising. So if it's positive, we're going to go up. If it's negative, we're going to go down. And how many we are running. And if it's positive, we go to the right. If it's negative, we go to the left. Usually the negative will be up in the numerator though. So most of the time in the run, we'll go to the right, but you can always switch it up. It doesn't technically matter. So these are our steps. Let's take a look at example 4. We're going to do this example together and then we'll do another one. So in example 4, they gave us our equation 2x plus y equals 2. And then after we graph it, we're going to identify the x-intercept. So our first step that we should notice here is this equation is not in y equals mx plus b. We need to first solve this equation for y, get it in the right form before we can start graphing it. So let's isolate this y here. We're going to get rid of the 2x by subtracting it. Let's subtract 2x from both sides. Now my equation is y equals, I'm going to put the variable term first, negative 2x, and then this is a positive 2, so plus 2. And now our equation is in the right form. This is y equals mx plus b. Y equals mx plus b. So now let's identify our slope and our y-intercept. So remember, our m is the slope. In this equation, our m is negative 2. And remember that our b is the y-intercept. And our b in this equation is 2. All right, so now we're ready to start our graph. I'm going to grab my piece of graph paper. If you don't have graph paper, that's okay. But you can print out some free graph paper from the link that I posted in Google Classroom. So let me just label my paper here. This is 3.5 example 4. And we're graphing the equation y equals negative 2x plus 2. Let me draw my coordinate plane on my paper. And it doesn't have to be that big. Let's label our axes as x and y. Put arrows on the ends of your axes. Okay, we're going to start to graph. So our first step here is we are going to plot the y-intercept. Our y-intercept we said is 2, so we're going to plot that point at 0, 2 on the y-axis. So I'm going to go up here on my y-axis to 2, and that is my y-intercept. My y-intercept is 2. Our next step is now we're going to use the slope to get to the next point. So I just want to remind you what we said here, that our slope is negative 2. But remember that we want to think about our slope as rise over run. So instead of just having it as just one number, I really want it as a fraction. So I'm going to rewrite this number as a fraction. Instead of just negative 2, I can write it as negative 2 over 1. Remember, any number can be over 1. Now I know that the rise is going to be the negative 2. and the run is going to be the positive one. So because my rise is negative, I'm going to go down, and my run is positive, I'm going to go to the right. Okay, remember that the rise stands for the change in y, so that's why we're going up and down, and the run stands for the change in x, so that's why we're going left and right. Okay, so I'm going to go back to my graph. I started at my y-intercept. Now let's use our slope. Our slope, the rise is down 2, right 1. And then I'm going to plot a point right here. Let's do that again. Down 2, right 1. The more you do it, the more points that you have to look at on your line, the easier it is to see your line. Let's do it one more time. From this point here, we're going to go down 2, right 1. Now let's say I wanted to continue my graph up into this direction as well. I just have to flip around both of the signs of my fraction. So instead of going down 2, right 1, I'm going to do the opposite. I'm going to go up 2, left 1, and notice how it is still in the line that's here. So instead of down, we went up, and instead of right, we went left. And you can always do that. You can always switch them both, but just be careful that both get switched. All right, so I have a nice line forming here. I'm going to use my straight tool, my straight edge tool here, so I can draw a nice line. And I'm putting arrows on the end because it's a linear function and lines go on forever. So there's our equation, just like that, and it is graphed on our coordinate plane. Our last step here in this question, it says we want to identify the x-intercept. So remember, the x-intercept is the point of the graph where the line crosses the x-axis. So here's our x-axis, and here's where our point is on the x-axis. So we're just going to state our x-intercept right here. Our x-intercept is at 1. So I'm going to go back to my paper, and let's write it down here. Our x-intercept equals 1. Okay, and that's all we have to do for that one. All right, let's do another one of these just to make sure that we understand what's going on. We're going to do number 9, monitoring progress 9. Okay, and I'm getting this from the bottom of the page, 139. So our equation for this is y equals 4x minus 4. Now look at this equation. This equation here is already in slope-intercept form. This looks like y equals mx plus b. So I'm ready to go. I'm ready to state my slope and my y-intercept. My slope of this line is the m. My m is the 4. Remember that we also want to think about our slope as rise over run. So instead of just saying it's 4, we can write it as 4 over 1. Our b, or our y-intercept in this equation, is the number at the end, and this is technically a negative 4 here. So negative 4 is our b. Okay, now we're ready to make our graph. I'm going to go over to my graph paper. Let's draw our coordinate plane on here. Label my axes x and y. Okay, we are going to start at the y-intercept. So the y-intercept is always the starting point. That's always where you begin from on your graph. So let's go ahead and plot this on the y-axis. So we're going to go ahead on the y-intercept, plot negative 4. So we're going to go 1, 2, 3, 4 down, and we're going to plot that point right there. That is our y-intercept. Let's go to the next part. We're going to go and use our slope now. Remember, our slope we're going to use as rise over run. So my rise is 4 and my run is 1. They're both positive. I'm going to rise up and run to the right. So I'm going to rise 4, 1, 2, 3, 4, and run to the right 1. Plot your point. Let's do it again. We're going to rise 4, 1, 2, 3, 4, and go to the right 1. Now technically you don't have to do more than 2 points. You really only need 2 points to draw a line. I just like to continue it until the end of my graph, but that's totally up to you. Okay, I'm ready to draw my line. And there is our graph. That is our linear equation. Okay, there's one more step here. We have to state the x-intercept of this graph. And let's look to see where this line is crossing the x-axis. And it just so happens to be right here at 1. It's just a coincidence that it was the same as this last graph. So our x-intercept is 1. And then we are done with this question. We're going to do one more together. Let's take a look at monitoring progress 10. So here's our equation, 3x plus y equals -3. You know, I changed my mind. Let's do number 11. Okay, in number 11, we have x plus 2y equals 6. Yeah, this is a good one to do together. All right, so the first step in this equation is that it's not in the right form. We need to get this in the correct form so that it's in y equals mx plus b, so I can see my m and the b. So let's go ahead and solve this equation for y. My first step to solve for y is let's get rid of the x. We're gonna subtract x from both sides. When I do that, I'm left with 2y equals, I'm gonna put the variable term first, this is a -x, and then the constant term second, this is a +6, so +6. Okay, we're almost there. Let's keep solving for y. I need to get rid of the 2 in front of the y. So I'm gonna divide both sides by 2. And don't forget, we're gonna do the heart method over here. So for our heart method, each of these terms is gonna get divided by 2. We have y equals -x over 2 plus, let's divide these two, it would be 6 over 2, or we could just say 3. Now I do need to rewrite this first term so that it is in the right form. I want my number before the variable. So think about what number is up here in front of this x. There's really a -1 in front of the x. Let's put the numbers together in their own fraction, and we're gonna push x to the side. So our equation is gonna be y equals, put the numbers in a fraction, -1/2, push x to the side, -1/2 x, and then plus 3. Now look at our equation. Now our equation is in the form of y equals mx plus b. So here's our m and here's our b. Okay, let's identify them just so we have them written down. Our slope in this equation would be this -1/2, and it's already a fraction. I can see my rise would be the -1, and my run would be the +2. My b is the y-intercept. So let's write our y-intercept down here. It would be 3. So remember, that's the y-intercept. All right, we're ready to make our graph. Let's go over to the graph paper. And I'm gonna make my coordinate plane here. Label my axes, x and y. All right, let's make our graph. So our graph, here's our equation, y equals -1/2 x plus 3. I'm gonna start at my y-intercept, which we said was 3. So I'm gonna go onto the y-axis up to 3. 1, 2, 3, pull out my point. My next step is now I'm gonna use the slope. My slope is -1/2. Remember, this is rise over run. Since my rise is negative, I'm gonna go down 1, and my run is positive, so I'm gonna go to the right 2. So I'm going down 1, right 2. Plot your point. Let's do it again. I can go down 1, right 2. Okay, if I wanted to, I could go the other way as well. Instead of going down 1, right 2, I could go up 1, left 2, and it would be the same point that's right along the line. Okay, again, you don't need to do this many points, but the more points you have, the easier it is to see. Okay, let's draw our line. We're gonna connect these points here with a nice line, and we're gonna put arrows on the ends. And there we have it. There's our equation, graphed. Now there is one more step here. The last step is we had to state the x-intercept. But look at our graph here. I didn't make my graph long enough to see the x-intercept, but that's okay because I can kind of figure it out, or I can adjust my graph to make it so that it's longer. Look at what's happening here. Remember in my slope, I went down 1, right 2, down 1, right 2. If I were to do the next point, I could easily figure out where that next point would be. If I went down 1, it would be on the x-axis, and I would go to the right 2. It would end up being right here on the x-axis. So let's figure out what that point is. I know this would be 1, 2, 3, 4, 5, 6. So my x-intercept would be over here at 6. So even though it's not necessarily graphed on the line, I can just imagine if it were to continue where it would be over here. So let's write that down. My x-intercept is 6. Now if I wanted to, I could go to the graph and I could just extend the graph a little bit and fix it so that I could see a little bit more. And if I went down 1, right 2, down 1, right 2, now I can definitely see where it's crossing my x-axis here. It's crossing right here at this point, which again is 1, 2, 3, 4, 5, 6. Okay, so you can always fix the graph and extend it, or you can just imagine where it would be.